Hey guys, today's video is the first part of this next unit on circuits. We just did Euler circuits. This unit is called Hamiltonian paths and circuits. Let's first look at this example. As you can see, there is New York, Miami, London, Rome, and Berlin. They are represented by the vertices. So number one says, how many vertices does this graph have? If you're counting all the dots, there are 1, 2, 3, 4, 5. Now, how many edges does it have? 1, 2, 3, 4, 5, 6, 7 edges. Those are all the lines. Next question says, is there an edge? So is there a line connecting New York to Berlin? Technically, no, because you have to go through London to get to Berlin. There's not like a direct flight. Then it says, how could we travel with this airline from New York to Berlin? Like I said before, we have to go from New York to London to Berlin. And that would be the answer number 3. Number 4 says, give example of a circuit. Remember, a circuit goes through all of the lines and repeats back at where you started. So for number 4, you can start at New York, then go to London, Berlin, Miami, maybe Rome, London, Miami, then back to New York. That is a circuit where you started and ended at the same spot and went through all of the lines. So, is there an Euler circuit in this graph? Yes. Well, we know that because all the degrees of the vertices are degrees of even. So 2, this is degree 4, degree 2, degree 4, 2. That's how you know there's an Euler circuit. Let's pretend now we are a city inspector, but we must inspect all the fire hydrants located at street intersections. To optimize our route, we're going to find a path that begins at the garage, G, visits each intersection exactly once, and by intersection we mean vertex, and then we go back to the garage. Let's look at the diagram. Here's G, this is where we want to start, and we want to get to each intersection. Intersection, like I said, were all of these vertices. So we want to get through all of these and then return back to the garage. What I want you to try to do is start at G and go through each of the vertices without lifting up your pencil, without going over a line twice, and return back to G at the end. So for example, you could start going in any direction. You can go maybe to H first. But the important thing is that you don't have to go through all of the lines. You only have to make sure you go through all the vertices. That's the difference between Euler and Hamilton, is that you only have to touch all the vertices and return back to G. You don't have to go through all of the lines. So try doing that. An example of an answer I got was G, H, F, D, C, A, B, E, J, I, G. Remember, it's not necessary to go over all the edges when we only want to visit the vertices. Let me know what questions you guys have on today's part 1 of Hamiltonian paths and circuits. Have a great day.